data structures using C, implementation of a doubly linked list. You're already familiar with the singly linked list. We have used that for Q, for polynomials, representation, etc. Now we come to doubly linked list. So what is doubly linked list? So in this lecture, we will know how to implement a doubly linked list. We'll go through the algorithm of creating a doubly linked list and then write in C functions to insert, to delete, to print the content of the doubly linked list. So here we have the pictorial representation of the doubly linked list. As you see, there is a head and there is its end with null. This is like the singly linked list here, forward link. At the same time, there is a backward link. I can come from the last, from any node, I can go to the previous node, and here also it will come to null. So these are each of the nodes contain a number, and there is going to be a forward link and a backward link. So let us see therefore the pictorial representation of a doubly node of a doubly linked list. As you see here, there is the node which contains a data item number 20, and there is a link to the next and link to the previous. These are two pointers. So this next question is, how do I create this new data type in C? As we have done it earlier, I say type def struct double link type number, and there is a link to the next node and link to the previous node. So this becomes therefore new data type, and I create a pointer variable called node of the type new data type, that is dbl lnk node. So this becomes a pointer variable. Then I want to assign some number to. Before doing that, I have to allocate memory using malloc. I'm allocating memory here, and then only I assign, for example, 30 to this number, and next and the previous. This next and the previous are going to point to null, or this is again the pictorial representation of the same node, contains 30, and the links next and the previous point to null. So this is how we are creating the new data type and creating a node. Now let us go into making a function to create a new node called make dbl link node. It will create a node which contains this number as the data item, and the next and the previous are going to point to null, as we have done it earlier. Same thing, but only different words. So it returns the address of this new node which contains this number, and the links point to null. So this is make dbl link node function. We are going to use this function now in the next function to insert a number into the doubly linked list. So here is again. So I want to create a node out of 80. As you see, 80 is the next and the previous point to null. And this node here, this node contains the address of this doubly linked node containing 80 as the data item. Now we come to various. Every time we have dealt with this different case 1, case 2, case 3. Here also we are going to have case 1 and case 2 and case 3. So let us see. Case 1 is always there is no list. There is no list. Then what we do is we make the incoming node the head of the list. How do I know that there is no list? So for example, here I have made the new node out of 30. Then I ask if head is equal to null. That is the indication that there is no list at all. Then what do? I make that new node the head of this list and return. So this is what we are going to do in case 1. Case 1, there is no list. Therefore, create the new node and make it the head of the doubly linked list. We come to, as you see here, new node is created. Head points to this node. Head contains the pointer to this node. New node is nothing but the pointer. So that is contained here in this variable called head. And this points to null, previous points to null, next points to null. We come to case 2. There is a list already, but the value on the incoming node is less than that on the head of the list. as we have done it earlier. So then what do? We make the new node the head of the list. So let us see how we are going to do that. So they make the head of the list. How to do that? So assign the pointer of the head to the next of the incoming node and make the incoming node the head of the list. I'll show it. So for example, here I've made a new node out of 12. I've assigned head to current. This is what we always do, previous and current. And then I ask this question: is new node number or just number is less than equal to head number or current number? So if that is so, then you say head new node next is equal to current. That is, you link that old head at the end of the new node. Current is nothing but the head, current contains head. Then you say current previous. Now current has become the second node. So current previous, therefore I have to link it to the new node. So I am linking therefore current previous to new node and make that new node the head of the list and return. So this is how I make the incoming node the head of the list, doubly linked list, because the number on the new node is less than that on the list. So for example, here I've got the new node which contains 20. This head points to current here, which has got 30. So what have I got to do? Therefore, new head, I am assigning head current is equal to head, or head is assigned to current. Now current points to here. Then I say new node next is equal to current. So this is linked, therefore new node is equal to current. Then what do? I have to current previous equal to new node. So I have to link that. So the therefore current previous is equal to new node. So current previous equal to new node. So that is linked. Now what have I got to do? I have to make this the head of the list. That is what is doing head. So this we have current previous is equal to new node. So now I say head is equal to new node. So assign this pointer to head. So that is being done, and automatically this is removed. This is no more there because head contains the address of the new node. So head to this, and from here it goes forward, and backwards you come like this, and this points to null. So this is how we link the new node which contains lesser number than that is on the head to the doubly linked list. So get the algorithm properly. Now we get into case 3. Case 3 is I have a list, ordered list. I have to insert the new number, node containing the new number at an appropriate position. To do that, what I do is I traverse the list, and we have done that traversing. I start with the current. If the number is greater than current, then I say previous equal to current, current is to current next. I come to a position where the previous contains the less number than the new node, and the current contains greater number greater than the new node. Then I have to link this. How do I do that? So what I do is I say previous next is equal to new node. That means I am linking new node to previous next. Earlier previous next was pointing to current. Now I am linking this new node to previous next. That is done. Then I have said new node previous. I have to link the therefore new node to the previous node. So new node previous equal to previous, that address of the previous node. So this way I have connected new node with the previous node. Now I have to connect a new node with the current or the next node. So therefore I say new node next is equal to current. So I have linked new node with the current node, the next node, and then current previous is equal to new node. I am linking therefore backward current previous to new node. So this is how it is done. I'll show you pictorially here, pictorially. So I have got a new node which contains 55. I've been asking this question, is 55 greater than 30? Yes. Therefore this became previous, this become current. Again I ask the question, is 55 greater than 40? Yes. This becomes previous, this becomes current. So I am here now. It doesn't go forward, it stops there. Now I have to link this new node with the previous and in between previous and current. So I have traversed and I have come to this position. Now what do? I say previous next is equal to new node. So previous next is equal to new node, that is linked. Now I have to say new node previous is equal to previous. This is previous. New node previous equal to previous. So previous is linked to the new node. Now I have to link new node to the current. So what do I say? New node next is equal to current. So that is new node next is equal to current. That is done. Now I have to say current previous equal to new node. So current previous equal to new node. So this is linked. Therefore current previous equal to new node, and automatically this is being cut. This is also severed. So now 55 is there in between the previous and the current node. So this is how I will deal with the last. Suppose there is a node which contains 90. How do I link it here? So that is shown in the program, in the function itself. Yes. So here I have got the complete function, insert double link node. This is number, this number. I create a new node containing that number. Then I assign head, current and previous. Please note, I have assigned head as the global variable. Otherwise, I have to pass it here. So to prevent all this confusion, I have declared head as the global variable, so it is available to any of these functions which we are writing. So that is what we are doing here. So this is case 1. There is no list, therefore make the new node the head of the list. Here in this case, number is less than that on the head number, so I have made it. So made the new node the head, then head next is equal to current, then the current previous is equal to head, as I've explained to you just now. Then here I do the traversing, but I've included here case 3, case 3 and case 4. Case 3 contains case 4 also. That is attaching the new node which has got the largest number at the end of the list. So that is done here. So therefore, if it reaches, if current next is equal to null, that means I have come to the current is there, but current next is equal to null. So what do I do therefore? Then I say current next is equal to new node, I return. So that is, I link the new node at the end of the list. Otherwise, I traverse the list, then I come out, as I showed, previous contains the less number, current contains the bigger number. I have to insert it in between, and that is done here as I've explained to you just now. So this is whole complete function, case 1, case 2, case 3. Case 3 contains also case 4. Case 4, linking it at the end of the list. Then this function will print the content of the list forward and backward. As you see here, I have assigned head to current, so I am here printing the content, number, etc., current number. So then it becomes previous become current. This is not needed. We need it. Yes, we need it here. So then current next, every time it is going to print the content of the current. Then it comes to the end here, because current next is going to be null. Then but previous will contain the address of the current node. So so then I'm assigning previous to current, and I want to go backwards here. So it is going to print backwards, current equals to current previous. So it backwards, this is forward and this is backward. So here I have the code for part of the program. As I'm showing you, I have declared here some constant, escape, right and left. I'm going to show you why I am doing that. That is, using these keys, forward key, backward key and escape key, I can navigate my doubly linked list forward or backwards. I shall show you. And here we have declared the new data type. Here is the head of the list, which is global variable. Here we have all these function in it, DBL list. So that means I have to initialize head to null, that is done here, and insert DBL linked list, print DBL linked list, key hit and display on key hit. So I'm going to take you through these two functions and show how we can use keys, forward key and backward key, to navigate doubly linked list. Now here we have got two. First is key hit. I want to find out which key is it. Is it forward key arrow or the backward arrow or escape? If it is escape, I come out of the program. If it is forward, I go for display the forward uh, uh, item on the node. So that is, and to do that I have to write this function. So I use get ch, gives me the code. Now in the case of these special characters, it is going to give the code twice. So there are two numbers are given. So first number is going to be 0 in all the special keys. First, if first number is 0, that means it's a special key. So then I ask if key is equal to 0, again get ch, get the correct ASCII code of these. As you see here, ASCII code of right is 77, left is 75. So therefore, if you hit the right key, then this key is going to have 77, it is going to return 77. I'm using that function here. As so here, for example, I've assigned head to current and I print the content of the current head. Then I want to do the traversing forward or backward. Then I ask, as long as key hit is not equal to escape 27. So then if I key is equal to right, then you say current is equal to current next, you print the content. If key is equal to left, you go previous, backwards you go by one node and print the content of the previous node. So this is a good exercise to go forward and backward and see whether your doubly linked list is really working properly. Thank you.